In the ever-evolving world of science, where new discoveries constantly challenge old ideas, it is both astonishing and deeply inspiring that one man's theories, developed over a century ago, continue to withstand the most rigorous tests of time and technology. Albert Einstein, widely regarded as one of the greatest minds in human history, transformed our understanding of the universe with a level of precision that still surprises scientists today. In 2026, as researchers push the boundaries of physics using the most advanced tools ever created, they are once again confronted with a remarkable truth: Einstein was not just right, he was unbelievably accurate. When Einstein introduced his theory of general relativity in 1915, he proposed a radical new way of understanding gravity. Instead of viewing it as a force acting between objects, as Isaac Newton had described, Einstein suggested that gravity is the result of massive objects bending the fabric of spacetime. This idea was revolutionary, not only because it redefined gravity, but because it introduced a completely new framework for understanding the universe. Space and time were no longer separate entities, they were interconnected, forming a dynamic structure that could stretch, bend, and ripple. At the time, many scientists struggled to fully grasp the implications of this theory. It was mathematically complex and conceptually challenging, and there was little experimental evidence to support it. Yet Einstein remained confident in his work, driven by a deep sense of curiosity and an extraordinary ability to visualize the unseen. He used thought experiments to explore how light and time would behave under extreme conditions, imagining scenarios that seemed almost impossible to test. Despite skepticism from some corners of the scientific community, his ideas gradually gained acceptance as evidence began to emerge. One of the earliest confirmations of general relativity came in 1919, when astronomers observed the bending of starlight around the sun during a solar eclipse. This observation matched Einstein's predictions and brought him international fame. However, this was just the beginning. Over the decades, numerous experiments and observations have continued to support his theory, from the precise movement of planets to the behavior of light near massive objects. But perhaps the most extraordinary confirmation has come from the detection of gravitational waves, ripples in spacetime, that Einstein predicted over 100 years ago. Gravitational waves are produced by some of the most violent and energetic events in the universe, such as the collision of black holes or neutron stars. These events generate waves that travel through spacetime at the speed of light, carrying information about their origins. Detecting these waves is an incredibly difficult task, as they are extremely weak by the time they reach Earth. It wasn't until 2015 that scientists, using the Laser Interferometer Gravitational Wave Observatory LIGO, were able to directly detect gravitational waves for the first time. This groundbreaking achievement earned the Nobel Prize in Physics and marked a new era in astronomy. Fast forward to 2026, and the field of gravitational wave research has advanced dramatically. Scientists are now able to detect these signals with greater sensitivity and precision than ever before. Recently, a particularly powerful gravitational wave event was recorded, originating from the merger of two massive black holes located billions of light years away. What makes this discovery so remarkable is the level of detail it provides. Using advanced data analysis techniques and artificial intelligence, researchers were able to reconstruct the entire event, from the initial spiral of the black holes to their final collision. Every aspect of the data matched Einstein's predictions with astonishing accuracy. The way spacetime warped, the frequency and amplitude of the waves, and the final outcome of the merger, all aligned perfectly with the equations he developed over a century ago. For scientists, this level of precision is both exciting and humbling. It suggests that Einstein's understanding of the universe was not only correct, but incredibly precise, even under the most extreme conditions imaginable. What makes this even more impressive is that these conditions, such as those found near black holes, are far beyond anything Einstein could have observed directly. Yet his equations continue to describe them with remarkable fidelity. This raises profound questions about the nature of reality and the power of human thought. How was it possible for one individual, working with limited tools and resources, to develop a theory that remains accurate in the face of modern scientific scrutiny? The answer lies in Einstein's unique approach to problem solving. He combined deep mathematical insight with imaginative thinking, allowing him to explore ideas that others might have dismissed. He was not afraid to challenge established norms or to think in unconventional ways. This willingness to question and explore is what set him apart and enabled him to make such groundbreaking contributions to science. Today, scientists are building on Einstein's legacy, using advanced technologies and interdisciplinary approaches to explore the universe in new ways. Artificial intelligence, in particular, has become a powerful tool in this endeavor. By analyzing vast amounts of data, AI systems can identify patterns and signals that would be impossible for humans to detect alone. In the context of gravitational wave research, AI is used to filter noise, enhance signal detection, and accelerate the analysis process. This allows scientists to gain deeper insights into cosmic events and test theoretical models with greater accuracy. Despite these advancements, Einstein's theory of general relativity continues to hold strong. It remains one of the most successful and well-tested theories in the history of science. However, researchers are also exploring the possibility that it may not be the final word on gravity. In extreme environments, such as those involving quantum effects or the early universe, there may be deviations from Einstein's predictions. Discovering such deviations could lead to new theories and a deeper understanding of the fundamental forces that govern the cosmos. For now, though, the continued success of general relativity is a testament to Einstein's genius. It serves as a reminder that great ideas can transcend time, and that the pursuit of knowledge is a continuous journey. Each new discovery builds on the foundations laid by those who came before, pushing the boundaries of what we know and opening new avenues for exploration. For viewers and learners, this story is more than just a scientific achievement. It is a source of inspiration. It shows that curiosity, creativity, and perseverance can lead to extraordinary outcomes. Einstein's journey from a curious thinker to a world-renowned scientist is a powerful example of what can be achieved through dedication and imagination. His work encourages us to think deeply, to question assumptions, and to explore the unknown with an open mind. In a world where information is readily available and technology is constantly evolving, it is easy to overlook the importance of foundational ideas. Yet it is these ideas that shape our understanding of reality and guide future discoveries. Einstein's theory of general relativity is one such idea, a cornerstone of modern physics that continues to influence research and innovation across multiple fields. As we look to the future, it is clear that Einstein's legacy will continue to play a central role in our exploration of the universe. Whether through the study of gravitational waves, the search for new particles, or the development of unified theories. His work provides a framework for understanding the complex and interconnected nature of reality. It challenges us to think beyond the limits of our current knowledge and to imagine new possibilities. Scientists may be surprised by just how accurate Einstein was, but perhaps the real surprise is not that he was right. It is how far his ideas can still take us. His theories are not just relics of the past. They are living tools that continue to shape the future of science. And as we continue to test, refine, and expand upon his work, we are reminded that the quest for knowledge is never truly complete. Einstein's accuracy is not just a measure of his intelligence. It is a reflection of his vision, his curiosity, and his unwavering commitment to understanding the universe. In 2026, as scientists once again confirm the validity of his ideas, we are reminded that true genius is not defined by a single discovery, but by a lasting impact that continues to inspire generations. Welcome to Einstein AI, where we explore the ideas that shape our world and the discoveries that define our future. Rocket